Now again, by what we have to multiply so that we can get x. Here x is, so by twice ax I have to multiply this. So plus twice ax into x is twice ax square. Then into a is the plus sign 2a square into x. To a into a square, twice a square x. Subtracting then minus sign, these two are cancelled out. And this is minus 2a square into x. So by what I have to multiply this? By minus sign. To obtain twice a square x, we have to multiply by into x by minus twice a square. Let me multiply by minus twice a square. Minus twice a square into x is minus 2a square into x. Same option, same is obtained. Minus 2a square into a is minus 2a cube. Now subtracting, this is plus sign, this is plus sign. These two are cancelled out, this is left over. So finally, what is left over? So we have obtained here, let me take pi 0 to a. What is the quotient? Quotient is here minus x square plus twice ax minus 2a square. This is quotient. The remaining value is plus 2a cube divided by a plus x. 2a cube is the remainder. Quotient is minus x square plus twice ax minus 2a square. This is the quotient. This is the remainder value twice a cube divided by a plus x. Further divided by a plus x. Well, it was not further divided. Well, it is constant value. This is with variable a plus x. Up to this point we have to leave it. This is into dx. Okay, so after division, this is proper division here. So after division we have obtained this value. Now this is to be integrated. Now let me write it here. So final volume is pi into, let me write again, 0 to a limits. This is minus x square plus twice ax minus 2a square plus this is twice a cube divided by a plus x into dx. Now this is to be integrated, simple integration. Okay, so now let me integrate this. That will be the volume obtained by solid generated from revolving this loop around the axis of x. Okay, this is the volume here. Integration of this minus x square is x cube upon 3 plus twice a x square upon 2 minus twice a square into x. So this is 2a cube into log of a plus x. Now limits 0 to a. Limits 0 to a. Now let me put the limits here. At a limit, this is a cube minus a cube upon 3. 2 to cancel out. This is a cube only. Because a into a square, that means a cube minus twice a cube. A square into a cube plus this is twice a cube into log of. Now let me write this properly. This is twice into a cube into log of a plus a 2a. Okay, and this is when we substitute 0 here, then x 0 log a, others are zeros because x. Wherever x is coming, x is 0, so multiply by x into something 0. Only this log value will be left over, log a, because a plus 0 is log a, minus log a. Okay, let me write this curly bracket, and this is the curly bracket here, and this is total value. So finally, what do we obtain? This is minus a cube upon 3, and if I take a cube out of the bracket, that will be better. This is a cube. Within bracket we have minus 1.3, this one, plus 1 here, minus 2 only, this minus 2, this is minus a cube, okay, no problem, plus this is 2 into log of, this is log m minus log n, log 2a upon a cancel out, only log 2. It is pi into aq minus 1.3 minus 1, this value, minus 2 plus 1 is minus 1, and this is plus 2 log 2. Now this is minus 4 by 3, minus 4 by 3. Now if I take, okay, here 3 was there or not? No, here 3 was not there. Okay, so this is the value minus 4 by 3. It is nothing but pi aq. So 2 log 2 minus 4 by 3. Now if I take 1.3 common, this is minus 4 by 3. If I take 1.3 common, that means pi aq upon 3 will be out. It will be 6 log 2 minus 4. Even 2 is again common. Let me take 2 common, so it's 2 pi aq upon 3. This is 3 log 2 minus 2. Simple. This is the final value. Final volume of the given curve of this solid obtained by revolving the loop around the x-axis is this 2 pi aq upon 3. For this 2 we have taken common again. This is 3 log 2 minus 2. Okay, and this is 2 pi aq upon 3. This is the final answer. So this is the question, cubic unit. This is volume here. We can write cubic unit, it's a unit, and this is the answer here. Question number, this is question number 13. We have completed now this exercise. Now further I have to take some complicated question based on Cartesian equations, because further I will take Cartesian equation, because this topic is involving a number of questions which have been asked by the students. There are some difficult questions which are kept in, okay, for another exercise. So next exercise will also be devoted to, okay, the Cartesian equations. Volumes after obtained by volume of solids of revolution. Volume of solids of revolution. Volume of solids of revolution. This is, okay, in Cartesian form. Cartesian equations. Further Cartesian equations I'll talk about, so that the topic is clear then. Okay, so up to this simple questions were there. Now I'll take some difficult ones, some simpler one also. Some more questions are there. Okay, see you then in the next lecture series. Okay, bye.